Hey guys, welcome back. So this is our third and final lesson for the week. So remember I told you there are 3. Make sure you are doing your video keyword submissions. That's a nice easy 10 points, so make sure you're doing it. Also make sure you're getting these assignments submitted. That's very important. Otherwise they are going in as zeros, as some of you are noticing. Alright, we'll go ahead and jump right in. We are looking at 7.10 today. So for the first part of this, it asks us to locate the center for each circle below. There are 2 circles below. I'm only doing the first one with you guys. So looking at this, we need to take and figure out how to find the center. So what do we know about circles? What goes through the center of every circle? Diameters. So we're going to draw 2 diameters, making them perpendicular bisectors, because that means that they're going to intersect at 90 degrees. Which will make sure that everything is nice and equidistant. So where those 2 intersect, now my lines are not very straight, so if you have a ruler, use a ruler. I don't have one right on hand, but this is what we have. So where they're intersecting, this point right here, that is the center of our circle. So for number 3, justify your work for finding the center of the circles above. Why does it work? Why does it pinpoint the center? So I have this all wrote out because there was a lot of writing, so I figured I'd save some time by having it all wrote out. Perpendicular bisectors using diameters or with diameters go through the center, and the bisectors are equidistant from the endpoints of the chord. So constructing 2 makes the intersection the center. So remember, any line that goes from one side of the circle to the other side of the circle is considered a chord. So that means where these intersect, this point and this point, they're equidistant from each other. So that means in the very middle where they intersect, that is our center. So that's how we can justify that. Give you a second to write. All right, number 4. In circle 1, draw a central angle and an inscribed angle that cuts the same arc as the central angle. What is the relationship between the measure of a central angle and its corresponding inscribed angle? So our central angle is this angle right here. It'd be 90 degrees because it's a perpendicular bisector that's formed it. Now, for our inscribed angle, that means it's going to have the same endpoints. So this right here and this right here, those are our endpoints. And it's going to lie, its vertex is going to be over here on the actual circle. So this is our inscribed angle. Now, the relationship for this, you guys should know it, is 45 degrees. So how do we go from having 90 degrees to 45 degrees? What's the relationship? Ooh, falling board. It's half. So the inscribed angle is half the central angle that form the same arc. So that's the relationship. So this arc here is 90 degrees, the central angle is 90 degrees, and the inscribed angle is 45 degrees. That's the relationship there. So the inscribed angle will always be half of whatever the arc is, and the arc and the central angle are the same, so that means it's also half of the central angle. Okay? All right. So moving on from our circles, now we're going to take a look at a lot of volume and surface area. So hopefully you guys should be fairly comfortable with this. We've done a lot with volume and surface area in the past when you guys were younger and things. Also, we did just look at volume and surface area on one of the other assignments this week as well. So hopefully that was a nice refresher and you're going to get a lot more here. So we are looking for, like I said, volume and surface area of each rectangular prism. So remember, rectangular prism, to find the surface area, you have to find the area of all the faces. For the volume, it's just length times width times height. So our 3 dimensions. So 9 times 8 times 20. So if we take 9 times 8 times 20, we're going to end up with 1,440 feet cubed. Remember your label. So if we're dealing with volume, it's going to be a measure cubed. So whatever our unit of measure is, cubed. All right, so now for surface area, like I said, we have to find the area of all the parts. So this front here and this back here, that's 9 times 8 for the area, so 72, and there will be 2 of them because front and back. This side over here is a 9 by 20, so is this side, so 9 times 20, which is 180, plus 180, because there's 2 of them once again. And then the top and the bottom, so a 20 by 8, so 20 times 8, which gives us 160 plus 160. We add all that together, and we're going to end up with 824 feet squared. So that is our surface area. So finding the area of all 6 of the faces, so you should have 6 values. There will be ones in common because we're dealing with a rectangular prism, so if they're across from each other, they should be the same size. But you'll add all those up, and then remember it's whatever your unit of measure is, squared for a label. All right, now how this is working is you have a picture for the first problem. The second problem, you're given a description. So a prism similar to the previous, so it looks just like this. It's similar, meaning all the angles are the same, but the sides are different by a certain scale factor, that has been enlarged, so that means it's getting bigger, by a factor of 4. So in each of these, it's going to be some prism that's similar, and it's either going to be enlarged or reduced by a certain factor. So because ours is being enlarged by this factor, when we're doing the volume, if we were to multiply all 3 of these by 4 and then multiply it together, we could find it. But an easier way is to take the actual volume we have, so the 1,440, and multiply it. Well, what's 4 to the 3rd power, since volume is a 3-dimensional thing? It's 64. So now we're just going to take the 1,440 times 64 to get our new volume, which is 92,160 feet cubed. So now for surface area, now remember, surface area is a squared value, so we're going to square our factor, so 4 squared is 16, so we're going to take our surface area, 824 times 16. So we're going to multiply those together, and we're going to end up with 13,184 feet squared. So when you're doing these, you're just going to take what that factor is, and for volume, you're going to cube it, and for surface area, you're going to square it, and then multiply it to the volume and surface area you found in the previous question. So they kind of go hand in hand with each other, which should hopefully make this a little easier. All right, so that's 6 through 9 are like that. You have prisms, and then we get to do the volume and surface area of cylinders. So lots of different shapes that we're working with here. Okay, so volume is actually our key word for this lesson since we're doing so many different volume problems. Volume is the key word for this lesson, so make note of that. All right, so finding volume of a cylinder, our equation is right here, pi r squared h, because it gets us the area of the base and then times the height. So on this one, I know it's a little hard to see, but the radius is 3, so this is going to equal pi 3 squared, and then our height is 8. 3 squared is what? 9, and 9 times 8 is 72. So we're going to end up with 72 pi feet cubed. So that is our volume. Now for surface area, we have this big long equation. Remember, we looked at this in a previous lesson. We have this big long equation for it. So we're going to have 2 pi, remember our radius is 3, times the height, which was 8, plus 2 pi radius squared, so 3 squared. All right, 3 times 2 is 6. 6 times 8 is 48 pi plus 3 squared is 9. 9 times 2 is 18. So we end up with 48 pi plus 18 pi. So if we add those together, we end up with let's see. Yeah, 66 pi. Sorry, looked at the wrong one. Almost said the volume one again. All right. So we end up with 66 pi for our surface area. And remember, feet squared because it's an area, not a volume. So we have squared on our feet. All right, once again, you're going to be given the picture and then a description relating back to the picture for each of these. So on this one, it says a cylinder similar to the previous that has been enlarged by 2. So for this, we're going to take our 2. If we're doing volume, what are we going to do to the 2? We're going to cube it. So we're going to take our 72 times, what's 2 to the 3rd power? 8. Excellent. And so 72 times 8 is 576 pi feet cubed. Now, because we left the 72 in terms of pi, we have to make sure we include pi in our answer. If you would have actually found what 72 pi was and had the decimal there, then you just have to multiply by 8 and not worry about it. But in my case, I left it off when I wrote it here. You can write it there as a reminder that you need to include pi for your answer. All right, now the surface area. So just like up here, when we did the surface area, we take that factor and we square it. So 2 squared is 4. So we're going to take our 66 pi and times it by 4. So 66 times 4 is 264 pi feet squared. Excellent. Once again, if you leave it in terms of pi, make sure you include that pi symbol there. If you find the decimal of it, then make sure you round it to the nearest tenth or hundredth. Either is acceptable. And don't forget your labels. All right, so this is our volume and surface area. Remember, volume is your key word for this lesson. Volume is your key word. All right, the next section we have to look at is a bit of a review. So it's going back and looking at our radians. So radians and degrees, like what we did in the previous, as well as area of sector and arc length. So lots of practice. So for those of you who really hate arc length and area of sectors, guess what? You're going to learn it one way or another. We'll keep on doing it. Okay, so for 14, we want to find the measure that is missing, either degree or radian. So we have 120 degrees. We want to find out how many radians that is. So we take 120 and we multiply it by pi over 180. Oops, that's supposed to be an 8. So 120 over 180 reduces to what? 2/3. So we end up with 2/3 pi for our radians. All right, the next one. So 18. 18 looks a little different from what we had dealt with before. So we have a decimal. We don't have pi in here anymore. But we're still going to take 4.7 times 180 over pi. So I'm going to put this all right in a calculator because trying to divide by actual pi is rather difficult. So 4.7 times 180. So I'm going to multiply those things first. And that's going to give me 846 over pi. And then divide by pi. And I end up with 269.3. On these, make sure, round it to the nearest tenth on these ones, okay? Round it to the nearest tenth. All right, and the last one, we have pi in this one, so another radian problem converting to degrees. So we've got pi over 6 times 180 over pi. Remember, the pi's cancel out, so we're left with 180 over 6, which reduces down to 30 degrees. Oops, forgot the degree symbol there. Okay, hopefully these aren't too bad. My guess is you'll end up liking converting between radians and degrees because they're fairly simple and you can just plug them all right into a calculator if you want. All right, on to our area of a sector. For those of you who are still struggling, follow along closely. I'm going to bring the screen up closer so you can see better. Okay, we take the angle we're given. So 100, we put it over 360. It's always over 360 because that's how many degrees there are in a circle, and we're looking at the area of just 100 of it. So we're looking at a fraction. Then we multiply it by, well, if we were finding the area of the circle, we just do 13 squared times pi. So that's what we do. That's how we find the area of the sector. So pi 13 squared. So now we take 100 and divide it by 360, and we have 5/18, and then we're going to multiply that by, well, what's 13 squared? 169. So we multiply it by 169, and then we multiply it by pi, and we end up with 147 point, I'm going to round it to the nearest tenth, so 0.5. It was 0.48, so I just rounded it up to sorry, you can't see that, up to 0.5. And that's what you do. You can type that whole thing right in your calculator. Just take the 100 divided by 360, multiply it by pi, then multiply it by 169, and there's your answer. All right, the last problem. So we want to find the measure of the length of the arc. So remember, this is using circumference, but same idea as what we did up here. We start with the angle. That is 150. So 150 out of 360 times 2 pi times the radius, which was 25. So we take 150 and we divide it by 360, and we end up with 5/12. So this is 5/12. Then we're going to multiply that by, well, 2 times 25 is 50 pi. So times 50, and then times pi, which is going to get us 65.5. It was 65.45. Feel free to round that up to 65.5. And this one will be meters, and this one will be, I forgot my label, centimeters squared. Don't forget your labels. They're important when we're dealing with area. So hopefully this is all making sense to you guys. These two, it's all about the formula, just plugging in what you have and then calculating it out, just plugging it all right into a calculator, quite frankly. So making sure you can figure out what goes where. But those two formulas are crucial. Same with these two formulas. So pi over 180 and 180 over pi. Once again, you can plug that all right into a calculator, okay? All right, final reminder, this lesson's keyword was volume. Make sure you're getting those keywords submitted as well as your assignments submitted. Have a wonderful week and happy mathing.